In video 9, we just talked about and introduced the concept of pressure and the formula behind it. Now I want to talk about atmospheric pressure and the numbers behind atmospheric pressure. In all the videos of the fun demonstrations we did last week, we talked about atmospheric pressure. And we said that everybody's under atmospheric pressure. So if you're happy like me to live at sea level, here I am at sea level, you have approximately 1 atmosphere of pressure being exerted on you. Now, 1 atmosphere of pressure is the same as 101.3 kilopascals. We just introduced the term Pascal in our last video, which is equal to 760 millimeters of mercury, which is equal to 14.7 pounds per square inch. Now, pounds per square inch is not isn't from the English system, but you'll see pounds per square inch a lot, especially if you're measuring tire pressure. So I want you to know how to convert between these 4 amounts. So I'm going to teach you how to convert between these 4 amounts, and since you're already good with dimensional analysis, it's not going to be that difficult. However, let's just talk very briefly. What if you were to climb to the top of Mount Everest? Now you have less atmospheric pressure on you. So the atmospheric pressure is going to be less than 1. And then what if you went to Death Valley? In Death Valley, you're going to have more atmospheric pressure on you, so the pressure on you is going to be greater than 1 atmosphere. In a little while, I'll show you a video where we boil water at less than 1 atmosphere. And this actually affects cooking time. If you live at a high altitude, your water boils at slightly less than 100 degrees Celsius. If you live in Death Valley, your water boils at greater than 100 degrees Celsius. So you actually have to vary cooking time. I grew up way above sea level, and we always had to use the high altitude directions on the recipe, because we had to increase our cooking time because our boiling temperature was lower than 100 degrees Celsius. All right, so these are all the same thing. If you have 1 atmosphere of pressure on you, you have 101.3 kilopascals on you, you have the pressure of 760 millimeters of mercury, or 14.7 psi. Now, how do we measure pressure? Well, we use a barometer, and in one of my labs, I had an old school barometer. It has a boatload of mercury in it, so we don't like to have that much mercury sitting in a high school lab anymore. It's just not safe. Okay, so basically a manometer is just a well full of mercury. Okay, so there's my mercury. And then you have an inverted tube. And there's the inverted tube, and the inverted tube has markings on it. And then what happens is atmospheric pressure pushes on the mercury and forces the mercury up the tube. So it would make sense if you were under 1 atmosphere of pressure, this mercury barometer would read, the mercury would go all the way up to 760 millimeters of mercury. That's where we get millimeters of mercury from. But then if you took your barometer to the top of Mount Everest, your mercury would be much, much less. Why? Because your atmospheric pressure is much, much less, because you're at the top of a mountain, and your mercury would probably stop about here. Whoops, my page just jumped. And it would be approximately at 250 millimeters of mercury. So this device is called a barometer. Like I say, at one of my schools, I had one for a while, but it's really not safe to have that volume of mercury in a classroom. So we measure atmospheric pressure with a barometer. Now, those of us who live in Florida, we know all about hurricanes, and we know when a storm approaches, the mercury goes down. And you'll hear the meteorologist getting very, very excited because as the pressure of the mercury goes down, it means that the storm is intensifying. And it's not that they want there to be a bad storm, but if you study weather, it's making for exciting data. So I understand why they're getting excited, even though no one wants to be destroyed by a storm. So the mercury goes down during a storm. All right, so how are we going to learn to convert between all of these numbers? Well, because you know dimensional analysis, it's the same concept. All of these can become conversion factors. You could say 1 atmosphere is equivalent to 101.3 kilopascals, or you could say 760 millimeters of mercury is equivalent to 14.7 psi, or 101. You could make all kinds of conversion factors. You could flip these over, but we're going to follow the same concept that we have all year. Given, and where are we going? So for example, if I said I have 385 millimeters of mercury, and I want you to convert that to kilopascals, and I want you to convert that to atmospheres. So first we're going to convert it to kilopascals, second we're going to convert it to atmospheres. Okay, so this is my given. I put down my given. I draw my grid. I put down where I'm going. My first step is I'm going to kilopascals. All right, now what have we learned over and over this year when we do dimensional analysis? Whatever you have here, you put here so that the units cancel. And we're going to kilopascals. And now this is my conversion factor. Remember, a conversion factor is an equivalence. So my conversion factor for 1 atmosphere for kilopascals is 101.3. For millimeters of mercury, it's 760. My units cancel. I'm left with what I want. Now I have to just do what the grid tells me to do. This line means divide. These lines mean multiply. Okay? So you're going to say 385 times 101.3 divided by 760. Or you could say, because math, 385 divided by 760, get your answer, times 101.3. So when you work that out, you should land up with 51.3 kilopascals. So pause the video and see if that's what you get. Now the second question asks you to convert it to atmospheres. So we're going to start with our given. 385 millimeters of mercury. And this time they want us to convert to atmospheres. Okay? Once again, I'm following all my dimensional analysis rules. If I have millimeters of mercury there, I have to put millimeters of mercury here. I'm headed to atmospheres, so I put atmospheres here. This is my conversion factor. A conversion factor is an equivalence. And here we go. 1 atmosphere is equal to 760 millimeters of mercury. These two things cancel. I'm left with what I want. This line here tells me to divide. So all I'm going to say is 385 divided by 760. And when I do that, I get 0.507 atmospheres. Notice I started with 3 significant figures. I need to end with 3 significant figures. Let's see if we did the right significant figures up here. Yep, I needed to end with 3 significant figures, and I did. So converting between these is very easy, provided you memorize that. And then once you know the equivalences, you can convert from any pressure to any other pressure.